The snow was 3 feet deep on Callum Henley's roof when the first crash echoed across the mining camp. He stood outside his cabin in the blizzard's brief lull, watching the tiered structure hold weight that would have crushed any normal roof, listening as another distant collapse sent desperate men scrambling into the January night. Before we begin, let us know where you're watching from in the comments below, and if stories of frontier ingenuity like this move you, hit that subscribe button because tomorrow's tale is even more remarkable than this one. The year was 1851. The Colorado Gold Rush was entering its third year, and mining camps dotted the mountain valleys where men willing to risk everything could strike fortune in a single season. But the risks were substantial. Avalanches, claim disputes, accidents with black powder, bitter cold, and structural failures killed prospectors with brutal regularity. Most miners accepted these dangers as the cost of potential wealth. Callum Henley was no different until the morning of April 12th changed everything he understood about mountain survival. Callum had partnered that season with Benjamin Quinn, a Massachusetts carpenter who had come west 2 years earlier. They had established a modest claim near Clear Creek, working a promising section of streambed that yielded enough gold dust to justify the brutal labor. Their cabin sat on flat ground near the water, built using standard mountain construction that Benjamin himself had designed. Steep pitched roof to shed snow, notched log corners, a stone fireplace, and solid craftsmanship throughout. It had survived the previous winter without issue. Benjamin was proud of the structure, often pointing out details to other prospectors who visited their claim. On the night of April 11th, a late spring storm moved through the mountains. The snow was heavy and wet, the kind that comes when temperatures hover just below freezing. By dawn, 18 inches had accumulated. Callum woke first and started the fire, while Benjamin slept in the small loft space they had built for extra storage and warmer sleeping during winter months. The cabin was warm, the coffee was brewing, and Callum was reviewing their sluice box plans for the coming week when he heard the first crack. The sound was sharp, like a rifle shot, and came from directly above. Callum looked up at the ceiling logs just as the second crack split the morning silence. He had no time to shout a warning. The ridgepole, a thick pine log that spanned the cabin's width and supported the entire roof structure, snapped under the accumulated weight of wet snow and the ice dam that had formed at the roof's edge. The failure was catastrophic and instant. The roof collapsed inward, bringing tons of snow, broken logs, and shattered roofing material down into the cabin's interior. Callum was near the door and threw himself outside as the structure came down. He landed in snow, rolled, and turned back to see the cabin crushed flat, the walls pushed outward by the weight, the entire building reduced to a broken pile of timber and snow in less than 5 seconds. Benjamin never had a chance to escape the loft. Callum dug through the wreckage for 2 hours, tearing at logs and snow with his bare hands until they were bloody and frozen. When he finally reached Benjamin's body, his partner had been dead since the first moment of collapse, crushed by the ridgepole that had failed. Other prospectors from nearby claims arrived to help, but there was nothing to be done except pull Benjamin's body free and prepare for burial. They buried him that afternoon on a hillside overlooking the creek, and Callum spent the night camped in the open, unable to look at the ruins of what had been their home. Callum abandoned prospecting the day after Benjamin's funeral. While other miners returned to their sluice boxes and claims, he walked through the scattered camps along Clear Creek and its tributaries, studying cabins with the focus of a man possessed. He carried a leather-bound notebook that had belonged to Benjamin, filling its pages with sketches, measurements, and observations that would have seemed obsessive to anyone watching. He started with the ruins of their own cabin. He measured the failed ridgepole's diameter, noted where the break had occurred, and examined the ice dam that had formed along the roof's lower edge. The steep pitch that was supposed to shed snow had instead created a trap. Light powder snow slid off easily, but heavy, wet spring snow clung to the roof surface. As it accumulated, meltwater from the warm cabin interior refroze at the cold eaves, creating a dam that prevented drainage. More snow piled behind this barrier, concentrating weight at the roof's weakest point until the ridgepole snapped. Over the next 8 weeks, Callum visited every mining camp within a day's travel. He found 3 other collapsed roofs from the same April storm, each showing identical failure patterns. He interviewed survivors who described hearing the same sharp crack before their roofs came down. He measured roof pitches, examined construction methods, and documented how different builders had attempted to solve the snow load problem. The conventional wisdom was universal and simple. Steep pitch sheds snow. The steeper the roof, the safer the structure. Prospectors built roofs at 45 to 60-degree angles, trusting that gravity would clear accumulation before weight became dangerous. Benjamin had built their roof at 50 degrees, following best practices he had learned in Massachusetts. But Callum's observations revealed a fatal flaw in this logic. Steep roofs worked perfectly with dry powder snow in deep winter. The crystals slid off before accumulating. Spring snow and wet winter snow behaved differently. The moisture content made it sticky, clinging to roof surfaces regardless of pitch. Steep angles actually worsened the problem. By creating the ice dam effect that had killed Benjamin, Callum found one exception during his survey. An old trapper's shelter on the western edge of the territory had a low-pitched roof that had survived 40 years of mountain winters. The structure was crude, barely habitable, but the roof showed no signs of failure. Callum spent an entire day examining it, measuring the shallow 15-degree pitch, noting how snow had accumulated evenly across the surface rather than concentrating at the edges. The trapper, a French-Canadian named Baptiste, explained his reasoning in broken English. "Let the snow sit," he said. "It keeps the cabin warm. Build strong enough to hold the weight, and winter becomes your friend instead of your enemy." Callum filled 20 pages of his notebook that day. The seed of an idea had taken root, one that contradicted everything every prospector believed about roof construction. The solution was not shedding snow faster, but holding it safely through strength and distribution. By early July of 1851, Callum had reached a conclusion that he knew would sound insane to every prospector in Colorado Territory. He sat in a boarding house in Denver, his notebook open to a fresh page, and drew the design that had consumed his thoughts for 3 months. A roof built in horizontal tiers, like steps, each layer reinforced and connected to distribute weight across the entire structure. Shallow pitch to prevent ice dams. Moderate overhangs to protect walls. Massive internal bracing to handle snow loads that would crush conventional construction. The design violated every principle of mountain building. It required 3 times the labor of standard construction. It demanded materials that most prospectors would never spend money on. It looked wrong, bulky, over-engineered, but Callum's calculations showed it would work. The tiered layers would distribute snow weight horizontally instead of concentrating it at roof edges. The shallow pitch would eliminate ice dam formation. The reinforced mass would handle loads that snapped conventional ridgepoles. He returned to Clear Creek in mid-July and made the mistake of sharing his concept with Frank Dawson, a veteran prospector who had worked Colorado claims since 1849. Callum spread his sketches on a camp table and explained the engineering principles he had discovered. Dawson listened for 5 minutes before laughing so hard he had to sit down. "You want to build a roof that holds snow instead of shedding it," Dawson said between laughs. "You want to make it heavy and complicated instead of simple and light. You want to spend 3 months building what takes 3 days. Son, that grief has broken your mind." Word spread through the mining camps with remarkable speed. By evening, a dozen prospectors had gathered to examine Callum's sketches. Charles Morton, a gray-bearded elder who had built cabins from Georgia to California, studied the drawings with a frown that deepened into disgust. "This is fool's work," Morton declared. "Every man here knows steep pitch saves lives. You are proposing to build a death trap." Others joined the criticism. The tiered design looked like a wedding cake, not a roof. The shallow pitch was suicide in snow country. The material costs were wasteful. The labor investment was absurd. A prospector named Davis suggested Callum was still in shock from losing Benjamin and needed time to recover his senses. Callum rolled up his sketches without arguing. He had expected resistance, but had underestimated how deeply prospectors trusted conventional wisdom. These were men who survived through proven methods. Innovation that contradicted their experience felt like betrayal of the knowledge that kept them alive. That night, camping alone away from the main settlement, Callum made his decision. He would build his roof exactly as designed. He would use his remaining savings to buy materials. He would spend however long it took to construct it properly. And when the next heavy snow came, his cabin would stand while others collapsed, or he would die, proving himself wrong. Either outcome would end the argument. Callum left for Denver on the first day of August with $200 in gold dust, everything he had saved from 3 years of prospecting. The trip took 4 days by horse through mountain passes, still clearing from winter snowpack. He arrived in the growing frontier city with a detailed supply list written in Benjamin's notebook and a resolve that bordered on reckless. His first stop was a hardware merchant on Larimer Street who specialized in mining equipment. Callum ordered 40 pounds of iron brackets in 3 different sizes, heavy bolts with square heads, and specialized lag screws that could bite deep into log wood. The merchant raised his eyebrows at the quantity but asked no questions. The iron alone cost $60, more than most prospectors spent outfitting an entire season. Next came the lumber yard, where Callum purchased tools he had never owned. A timber scribe for marking precise angles, a broad axe for shaping logs. A 2-man crosscut saw he would have to operate alone, and a draw knife with a blade nearly 2 feet long. He bought a barrel of coal tar for waterproofing and 3 gallons of boiled linseed oil. The yard foreman asked what he was building. "A cabin," Callum said. The foreman looked at the tools and shook his head. "That is some cabin." The most unusual purchase came from a surveyor's office near the center of town. Callum had noticed the business during previous visits but never had reason to enter. Inside, he found a middle-aged man named Peterson who had worked railroad construction in Pennsylvania before coming west. Callum explained that he needed information about load-bearing calculations and weight distribution across horizontal surfaces. Peterson was intrigued enough to spend 2 hours sketching engineering principles on large sheets of paper. He showed Callum how to calculate dead loads versus live loads, how compression forces moved through stacked timber, how cross-bracing transferred lateral stress into vertical support. He pulled down a textbook on bridge construction and walked Callum through diagrams of truss systems and beam reinforcement. When Callum mentioned he was designing a roof to intentionally hold heavy snow loads, Peterson stopped smiling. "That is ambitious," he said carefully. "Most builders try to avoid snow load entirely." Callum showed him the tiered design. Peterson studied it for a long moment, then began making calculations on a separate sheet. "If you reinforce here and here, and if you use iron brackets at these connection points, and if your logs are sound and properly seated, this might actually work." Might. Callum bought the textbook for $5 and paid Peterson another $3 for the calculations. He left Denver on August 6th with a wagon full of materials, $70 remaining, from his savings, and knowledge that felt both empowering and terrifying. Other prospectors would spend that money on supplies to last a full season. Callum had spent it on a single structure that everyone believed would fail. The return journey took 6 days, pulling the heavy wagon. Callum began construction on September 3, 1851, on a plot of high ground half a mile from the main mining camp. The location was deliberate. Elevated position for drainage, clear sight lines in all directions, and enough distance that the daily mockery from other prospectors would require them to make a special trip. Most did not bother. They simply watched from afar and shook their heads at the fool on the hill. The first 3 weeks were spent on work that no prospector considered necessary. Foundation preparation. Callum marked the cabin's perimeter using stakes and string, checking measurements repeatedly until the corners formed perfect right angles. Then he began digging. The trenches were 18 inches deep and 2 feet wide, following the entire perimeter of the planned structure. Other miners built directly on cleared ground, trusting log weight to keep cabins stable. Callum was engineering for permanence. He filled the trenches with stones gathered from the creek bed, each one selected for flat surfaces and tight fit. The work was backbreaking. Each stone had to be carried uphill, positioned carefully, and tested for stability. He used smaller stones to fill gaps between larger ones, creating a solid mass that would not shift under weight or freeze-thaw cycles. On top of the stone base, he laid a course of the flattest rocks he could find, using a level to ensure perfectly horizontal surfaces. Frank Dawson rode up on September 23rd to observe the progress. He sat on his horse for several minutes, watching Callum place stones with meticulous care, then called out loud enough for his voice to carry. "You are building a foundation for a palace, not a mining cabin. By the time you finish, winter will be here, and you will freeze to death in that fancy hole in the ground." Callum did not respond. He had learned that arguing with skeptics wasted energy better spent on construction. Dawson rode away, and Callum continued placing stones until the light failed. The foundation work was completed on September 28th. By Prospector standards, Callum had wasted a month accomplishing nothing visible. No walls stood, no roof protected supplies from weather. Just a rectangular outline of stacked stone that looked like the beginning of a root cellar or a grave marker, depending on who was judging. Charles Morton visited the site in early October and declared it a monument to a dead partner's ghost. The comment spread through the camps, and the name stuck for a while. Other prospectors referred to Callum's project as the Monument or Benjamin's Memorial. The mockery had an edge of discomfort to it, as though they were watching a man's grief take architectural form. Callum ignored them all. He had calculated that his foundation would support 40,000 pounds of vertical load distributed evenly across its surface. A standard cabin roof might carry 5,000 pounds during heavy snow. His design would carry 3 times that amount. The foundation had to be perfect, or everything built on top would eventually fail. The walls went up quickly by Callum's standards, slowly by anyone else's measure. He selected logs with obsessive precision, rejecting any timber with excessive taper or visible rot. Each log was stripped of bark, shaped to consistent diameter, and fitted so tightly that gaps were measured in fractions of an inch. By mid-October, the walls stood complete at 8 feet high, solid and square on their stone foundation. Then the roof construction began, and the design that had existed only in sketches became visible reality. Callum started with massive base beams that spanned the cabin's width. These were not simple ridgepoles like those used in conventional construction. They were full logs, 12 inches in diameter, notched to sit securely atop the wall logs and reinforced with iron brackets bolted through the wood. He positioned 4 of them parallel to each other, spacing them exactly 3 feet apart. On top of these base beams, he built the first tier. Shorter logs laid perpendicular to the base beams, each one secured with lag screws and additional brackets. The result was a flat platform of timber, solid enough to walk on, covering the entire cabin footprint. This first tier extended beyond the walls by 18 inches, creating the moderate overhang that would protect the structure below. Then he built the second tier on top of the first, using the same technique but with slightly shorter logs, creating a stepped effect. The second tier was smaller than the first, set back by 1 foot on all sides. More brackets, more reinforcement, more careful measurement to ensure level surfaces and proper weight distribution. The third tier went up in early November, stepped back again, creating the wedding cake appearance that made passing prospectors stop and stare. The design looked wrong. Roofs were supposed to be simple, sloped, lightweight. Callum's creation was massive, geometric, deliberately complex. The tiered structure rose nearly 4 feet above the top of the walls, far thicker than any roof built by men who knew what they were doing. Frank Dawson brought 3 other miners to observe the spectacle on November 8th. They sat on their horses at a distance, studying the strange construction like men examining a curiosity at a traveling show. "That is the stupidest thing I have ever seen built," Dawson announced. "He is creating a snow trap that will crush him in his sleep." The other miners agreed. One suggested placing bets on which week of winter the collapse would occur. Another wondered if Callum would at least have the sense to sleep outside once. Heavy snow began falling. They rode away laughing, their voices carrying in the cold air. Callum worked through their mockery, adding cross-bracing between tiers, installing internal support posts that ran from the foundation to the uppermost tier, creating a skeleton of reinforcement invisible from outside. He waterproofed each tier with coal tar, sealed joints with oakum, and verified every connection twice. Winter was coming, and his roof was not yet finished. The first snow fell on November 16th, while Callum was installing the final waterproofing layers. Light powder that dusted the tiered structure and melted by afternoon. But the warning was clear. Heavy weather would arrive soon, and his cabin was still unfinished. He worked through shorter daylight hours with hands that cracked and bled from cold and constant labor. The chimney required a week of careful stonework. Callum built it through the center of the tiered roof, creating a passage that maintained structural integrity while venting smoke efficiently. He used flat stones mortared with clay mixed with sand and lime he had purchased in Denver. The chimney extended 4 feet above the highest tier, tall enough to draw properly and prevent downdrafts that would fill the cabin with smoke. The final weatherproofing took another 10 days. Callum stretched canvas across each tier before applying layers of coal tar mixed with pine pitch. The combination created a flexible waterproof membrane that would expand and contract with temperature changes without cracking. Over this, he laid split shingles on the uppermost tier only, creating a final barrier against wind-driven rain. Interior work consumed the last weeks of November. Callum built a sleeping platform, installed shelves, constructed a table and single chair from leftover lumber. He chinked the walls with the same clay mixture used in the chimney, packing it tight between logs. He installed a heavy plank door with iron hinges, hung shutters, over the single window, and built gun ports into 2 walls for defense or hunting. On December 4th, he moved his supplies into the completed cabin. 3 months and 1 day after breaking ground, the structure was habitable. Callum lit the fireplace for the first time and watched smoke draw cleanly through the chimney. The tiered roof held the heat inside with remarkable efficiency. The multiple layers created dead air spaces that insulated better than any single-plane roof could achieve. The first significant snow came on December 9th. 6 inches of light powder that accumulated evenly across the tiers, exactly as Callum had calculated. The step design created horizontal surfaces where snow settled in distinct layers rather than sliding off or concentrating at edges. The weight distributed across the reinforced structure without any visible stress. Inside, the cabin remained warm, the additional snow providing extra insulation that reduced the amount of firewood needed to maintain comfortable temperature. Other prospectors' cabins performed as expected. Their steep roofs shed the light snow easily, and no problems appeared. Callum's design looked merely strange, not vindicated. The real test would come with heavy, wet snow or sustained accumulation over multiple storms. Charles Morton visited in mid-December, ostensibly to borrow tools but clearly curious about the interior. He examined the thick walls, studied the way the tiered roof created a cathedral-like ceiling space, and tested the door's solid construction. "Still seems like wasted effort to me," Morton said. "But at least you will not freeze before spring proves you wrong." Callum accepted the backhanded assessment without comment. The winter of 1851 to 1852 was unremarkable until mid-January. Normal snowfall, cold temperatures, the usual hardships of mountain life. Prospectors huddled in their cabins during storms and worked their claims during clear weather. Callum's tiered roof accumulated snow in distinct horizontal layers that built up gradually across the stepped surfaces. The structure showed no signs of stress, but neither did anyone else's roof. The design remained an expensive curiosity. On January 14th, the weather changed. A massive storm system moved into the Colorado mountains from the southwest, bringing moisture-laden air that collided with Arctic cold descending from the north. The combination created conditions for heavy wet snow, the same type that had killed Benjamin 9 months earlier. The storm began before dawn on January 15th. Within hours, snow was falling so heavily that visibility dropped to a few yards. The temperature hovered just below freezing, perfect conditions for the dense, sticky snow that clung to every surface. By evening, 8 inches had accumulated. By midnight, 16 inches. The snow continued through the 16th without pause. Callum watched from inside his cabin as the tiered roof performed, exactly as engineered. Snow piled evenly across each tier, creating multiple horizontal layers that distributed weight across the entire structure. The moderate overhangs caught snow that protected the walls below, while the extended surfaces spread the load. The internal bracing and iron brackets held firm. The cabin creaked occasionally as timber settled under increasing weight, but the sounds were normal, not the sharp cracks that preceded catastrophic failure. Other cabins in the mining camp began showing problems on the second day. James Whitfield's roof developed a visible sag along the ridgeline as ice dams formed at the eaves and snow accumulated behind them. The steep pitch that was supposed to prevent this exact problem had instead created it. Wet snow stuck to the roof surface instead of sliding off, and meltwater from cabin heat refroze at the cold roof edges. On the morning of January 17th, Whitfield's roof collapsed. The failure happened at dawn, with a crack loud enough to wake men in nearby cabins. Whitfield escaped through a window before the full collapse, but his shelter was destroyed, his supplies buried under tons of snow and broken timber. He stood in the storm wearing only his sleeping clothes and boots, staring at the ruins. 2 hours later, another roof failed a quarter-mile away, then a third before noon. The pattern was identical to the April storm that had killed Benjamin. Heavy, wet snow, ice dam formation, concentrated weight at roof edges, ridgepole failure, catastrophic collapse. Callum's cabin held steady. By the evening of the 17th, 3 feet of snow sat in layered tiers across his roof. The weight was immense, thousands of pounds distributed across the stepped structure. The design was working precisely as calculated, holding loads that were destroying conventional construction throughout the mining camp. The storm finally broke on the morning of January 18th. Callum stepped outside his cabin during the first clear hour in 4 days. The sky was still heavy with clouds, but the snow had stopped falling. He wore his heavy coat and fur-lined boots, carrying a shovel to clear a path from his door. The scene that greeted him was exactly what his months of obsessive calculation had predicted. His tiered roof held 3 feet of snow distributed evenly across the stepped surfaces. Multiple horizontal layers stacked precisely as designed, the weight spreading across reinforced tiers instead of concentrating at weak points. The moderate overhangs showed slight sag but no structural failure. The chimney stood straight, smoke curling from its top. The cabin beneath remained solid, warm, intact. Down the slope toward the main mining camp, 5 collapsed roofs were visible even from Callum's elevated position. Piles of broken timber and snow marked where cabins had stood 3 days earlier. Men were digging through wreckage, salvaging what they could, seeking temporary shelter with neighbors whose structures had survived. James Whitfield appeared first, trudging through waist-deep snow up the hill toward Callum's cabin. He had spent 2 nights in Frank Dawson's overcrowded shelter and looked exhausted, frostbitten, desperate. He stopped 20 feet away and stared at the tiered roof, at the tons of snow it held without visible strain, at the design every prospector had called stupid. "Your roof is still standing," Whitfield said. The statement carried disbelief and something close to awe. Callum nodded. Whitfield moved closer, studying the tiered construction, the way snow sat in distinct layers, the engineering that had seemed like madness 4 months ago. "Can I shelter here until I rebuild?" he asked. Callum stepped aside and held the door open. By midday, 3 more men had arrived. Charles Morton came without speaking, simply studied the roof from every angle, running calculations in his head. A younger prospector named Davies asked permission to measure the tier dimensions and sketch the design. Frank Dawson arrived last, riding up on his horse, sitting in silence for several minutes before dismounting. "I was wrong," Dawson said. The admission came without preamble or excuse. "Every man here told you this would fail. We laughed at you. We called it a monument to grief and a suicide trap." He gestured at the cabin, at the roof holding weight that had crushed 5 conventional structures. "This is the soundest construction in Colorado territory. I was wrong." Callum accepted the statement with a slight nod. Inside his cabin, men huddled around the fireplace, warming themselves, marveling at how the thick roof and layered snow created insulation that kept interior temperature comfortable with minimal firewood. The same snow that had destroyed their homes was protecting this one. By evening, 7 men were sheltering in Callum's cabin, sleeping on the floor, sharing the space he had built for himself alone. They talked in low voices about roof angles and weight, distribution, about the fatal flaw in steep-pitch design, about engineering principles they had never considered before watching them save their lives. Spring came to the Colorado mountains in late March of 1852, melting the snow that had sat on Callum's tiered roof for 2 months. The structure had held through 4 additional storms, each one adding weight that the reinforced design distributed without failure. When the last snow finally melted, the cabin stood exactly as built, no sagging, no damage, no compromise to its integrity. Edward Pierce began rebuilding his collapsed cabin in early April using Callum's design. He spent a week studying the tiered construction, measuring angles, examining how the iron brackets connected each layer. Pierce was a methodical man who had lost everything in the January blizzard except his life. He bought materials in Denver using money borrowed from other miners and spent 2 months building a roof that looked like a smaller version of Callum's original. By summer, 3 more prospectors had adopted the tiered design. They called it the Henley roof, though Callum never promoted the name or claimed any credit for the innovation. He simply returned to prospecting, working his claim with the same quiet focus he had brought to construction. Men asked him questions about load calculations and tier spacing, and he answered with precise technical details, sharing his knowledge as freely as he had shared shelter during the blizzard. The design spread through mining camps along Clear Creek, then into other Colorado settlements. Not every prospector adopted it. Some still trusted steep-pitch construction despite the January failures. But men who had seen roofs collapse or who valued certainty over tradition began building tiered roofs reinforced with iron and engineered for weight distribution rather than shedding. Callum left Colorado in the spring of 1855. Gold production from his claim had declined, and reports of richer strikes in California drew him west. He sold his cabin to a family of settlers for $200, exactly what he had spent on materials 4 years earlier. The family lived in that cabin for 18 years, raising 3 children under the tiered roof that never failed through Colorado's worst winters. By the 1860s, mining camps throughout the Rocky Mountains included variations of Callum's design. The specific details varied based on available materials and individual skill, but the core principles remained consistent. Shallow pitch to prevent ice dams, tiered construction for weight distribution, reinforced connections using iron hardware, and moderate overhangs for wall protection. Historians estimate that several dozen lives were saved over the following decades because prospectors built roofs that could withstand snow loads that would have crushed conventional construction. The phrase, "built like a Henley," became shorthand in Colorado mining. Communities for construction that exceeded minimum standards, for engineering that prioritized survival over convenience, for the kind of careful work that kept men alive through mountain winters. Callum Henley died in 1873 near Sacramento, California, having never returned to Colorado or the cabin he built. But the tiered roofs remained, weathered and solid, protecting new generations of mountain inhabitants. His legacy was not written in records or celebrated in stories, but built into timber and iron, standing silent proof that intelligence applied to fundamental problems could outlast any individual life.